In this video, I want to show you how to generate the printouts that are useful when working with proportions. Now I'm going to show you how to work with this, a single proportion, comparing two proportions, or working with three or more proportions, all in this same video. So let's get started. If we have a single population and we're trying to estimate a population proportion, or maybe we're doing a test of hypothesis for a single population proportion, the menu that we're going to go to, it's really easy to work with, we're going to go to hypothesis test and we're going to go to one proportion. Now it doesn't matter if we're doing confidence intervals or test hypothesis, this menu will work for us. And when we go there, it's going to ask us for a sample size and number of successes. Now you see the data set in the background, that's not used for this particular analysis, we'll get to that in a second. But let's say we've taken a sample of 300 students and we have found that 72 of them have a tattoo. Maybe we're trying to do a confidence interval for the proportion of all students that have a tattoo, or maybe we want to do a test of hypothesis, some topics that we cover during class. Well, if I want to do a confidence interval, that's really all the information I need, and then I put in the confidence level down here. But when I go and say OK, it's going to say, oops, you need a hypothesized value or a null hypothesis value. And so we're just going to put in a value of 0.3 here. If you're doing a test of hypothesis, if someone asks test to determine if the proportion of all college students who have a tattoo is less than 30%, you're going to go do that. And so the test of hypothesis information is going to be found right here on the printout. But then we hit OK, and we're given some information. Now, the test hypothesis information is right here. And one of the things that Statistics 10 does incorrectly, we ask for a less than test, and it doesn't give me the less than sign. It gives me an equal to sign there, which is kind of weird. In fact, if I go and change this to a not equal to, it keeps an equal sign. There's a flaw in the program. One thing that I'll notice, or I'll point out to you, that notice the p-value for the two-tailed test is 0.0233. When I go to the one-tailed test, it's doing the math correctly. It's just labeling the alternative hypothesis incorrectly. So kind of a weird little snafu with Statistics 10. The confidence interval we would use is always going to be the top one down here. So generating confidence intervals, generating test hypothesis for a single proportion is all done out of that menu. Okay, and again, let me take you back to the menu that I used. You put in the sample size, you put in the number of successes, you need a hypothesized value. If you're working with a confidence interval and you don't really care, you can put in any number between 0 and 1 here. It'll be fine. You can choose any alternative. Obviously, if you're working with a test hypothesis, you have to set these two pieces up correctly. And when you get the printout, pay no attention to the alternative hypothesis you see, or the sign you see. The numbers are all good. We use what's called the uncorrected information here and the simple asymptotic confidence interval here. So that's working with a single proportion. Similarly, if we're working with two proportions, we're going to go down and choose the two proportions menu. So I'm going to go in there, and now it's going to ask for both sample sizes, or both sample information. So let's say we're comparing the number of students, or the proportion of students that have a tattoo between males and females. And maybe with the females, that's what I said, there was 300. I think I said there was 72. So let's say there were 40 females and 32 males. Again, if I'm doing a confidence interval, I'll make this a 90%. And I have my alternative that I get to choose. We hit OK to get the printout. You can see the test hypothesis information is given right here. Again, we're going to use the uncorrected row, and the confidence interval information is given down the bottom. There's only one to look at, so that's the one that we obviously want to use. And we're going to interpret it like we've done before. Look at the signs on the endpoints, the negative and the positive sign here. We're not going to be able to determine the difference between the proportions. So again, let me head back. Now notice here that the not equal to sign did show up correctly. So it's just a single proportion where statistics has its problem. Let's see what happens when I change to a greater than test. Yep, worked fine. P-value's changed, looks good. So that's comparing two proportions. Now, the last analysis I want to look at in this video is where we do what's called the one-way study. And it's a chi-squared analysis. And the place that we're going to find that is I believe it's here in associations. It is the multinomial or the chi-squared test. Probably the chi-squared test. Nope. Let's try the multinomial. Statistics has changed some of its terminology over the years. Let's see. Yep, that's it. Okay, hypothesized proportions and observed frequencies. Now, an older edition of statistics allowed me to use the expected counts. We'll see what this one does. Observed frequencies. We'll put the observed there. And I'm going to put the expected here. Let's see what it does. Yeah, it works fine. Another way of doing this analysis, let me come back here. Let's go back to your data. Let's go data, insert, variables, and we'll call proportion. Let's say after, and we'll say proportion. And I'll say OK. When we get to this analysis, we're going to see that someone's hypothesizing certain proportions for all the different categories. There's 4 categories. We're going to assume that the proportions are equal, so they'd be 0.25. They have to sum up to 1. And so we can do the proportions. Now, the last time I did this, let's go in back again to the association test. I don't know why I struggle to find this. Multinomial. Okay, the last time I went in here, the hypothesized proportions, I put in the expected counts. And the older versions of statistics, and apparently this one too, allow you to put in either the expected counts or the proportions. So let me put the proportions in this time, and we're going to get the same printout. Yeah. So if you give it the expected frequencies, that's what I did the last time, it knows, well, there's a total of 400, and there's 100 in each, so they're 25%. In this case, if you give it the hypothesized proportions, it can do the math. It says there's a total of 400, so the expected frequencies are going to be 100. But we're going to look at this kind of information here. The test statistics called the chi-square, the p-value, which we've been interpreting all semester. So that's how we generate what's called the multinomial test in statistics. We're going to call it the one-way categorical test when we look at it in class. So that's how you generate the printout for 3 or more proportions. And hopefully that helps. So single proportion, comparing 2 proportions, 3 or more proportions, you now have the tools to generate the printouts that are necessary. If you have any questions, you know how to get them answered. So long.